Okay, guys, this is one of the last chapters, as I said. It is rapid tooling. We'll be talking about additive manufacturing applications for the fabrication of tools. Can anyone tell me what is a tool in manufacturing? We are using additive manufacturing to produce such tools, but what are they? What kind of things are they? Why do we need such tools in manufacturing? And we are using this additive manufacturing technology to produce tools, and these tools will be used in different manufacturing processes. They will not be used in the same additive manufacturing. So what are tools? Can anyone tell me?
Some templates may be used to ease other manufacturing processes.
Yes, in general, we can say that. For instance, what is a tool in turning machine?
A drill cutting tool.
Cutting tool. What about tools in, let's say, milling? Again, you have tool, you have fixtures sometimes. What about tools in casting? What are the tools? The molds usually can be considered as tools. What about, let's say, electro-discharge machining? What are the tools we use in electro-discharge machining? The electrodes actually are the kind of tools we are using such specific manufacturing technology. Now we'll be talking about briefly how we can use additive manufacturing technology to produce such tools so that our other manufacturing processes will take less time or they will be much easier. So we can say that the tools are kind of patterns, molds, or impressions from which the final part can be taken. And in the short run tooling, we prefer to use prototype tooling or soft tooling, and it's possible, obviously, with additive manufacturing. For the long run tooling, it's better we have high quality tools, since we will be using these tools for mass production, which means that the same tool will be used maybe 100,000 times. But if it's a short run tooling, then in order to decrease your costs, your time spending on the fabrication of tools, it's better you go with additive manufacturing.
Hocam bir şey sorabilir miyim?
Sure, Güray.
Hocam bu turning machine'lerde falan cutting tool'ları nasıl yapıyorlar additive manufacturing'le? Yeterince sağlam oluyor mu? Sonuçta metal kesmek için
No, I didn't say that we are producing such tools with additive manufacturing. I just give an example to a tool. I didn't say that we can produce them with additive manufacturing.
Tamam hocam, ben yanlış.
They are produced mostly, especially carbides, are produced with powder metallurgy. They mix the proper powders and then press, do sintering, so do coating on top of the surface, but it's quite challenging with additive manufacturing. Yes, John? No question? Okay. So why do we need to produce actual tools? Why don't we use direct digital manufacturing? There are several reasons. First of all, we cannot use direct digital manufacturing if the cost is not effective, if the additive manufacturing techniques are not cost efficient, then you may go with conventional approaches, but use rapid prototyping or additive manufacturing as for the production of just the tools. Another reason why we can't use additive manufacturing for the final product might be the materials. The materials we have for the additive manufacturing machineries may not be proper for the final product. Again, if that's the case, we can go with producing the tools rather than producing the final products with additive manufacturing. And another thing we need to use additive manufacturing for tooling is that you may need to see whether the design tool is applicable for our purpose or not. And this is quite a wise solution. We can produce prototype tools and then decide whether it's a nice tool, a nice design for the desired tool or not. If that's the case, then you may produce the same tool from different materials by using different approaches, not additive manufacturing approaches. Another thing we are using additive manufacturing for the production of the tools is that they are obviously quickest way, and in a shorter time you can obtain such weird designs, such special tools which are required in your other manufacturing operations. Here you see an example, for instance, injection molding inserts, not the mold itself, but the inserts. As you know, in some specific cases, in some specific applications of injection molding, we need to have special inserts. You may have a mold, and then from time to time, you may need to add specific features. And to have such features, you need to use inserts, and these inserts are easily produced with the help of additive manufacturing technologies. John, do you have a question? You're always unmuting yourself? No question? So then why are you unmuting yourself? No response? Okay. Here's another example. For instance, you may have this huge, let's say, kind of mold side, and then you can produce this internal, let's say, parts of the mold, and they are produced with the help of polyjet type of additive manufacturing technology, and you can consider these as inserts. For instance, you may be producing such special products for 10 times, and in the next production stage, you may simply remove these green parts and have another insert. So with the help of it, you don't need to replace the whole mold for your application. By only removing these green regions, you can decrease your overall costs. And these parts are again kind of inserts to hold the mold parts together. Here's another example. These are fabricated with the help of metal laser sintered tool sets. So they use such a kind of an operation to have the mold. This is the mold, and they are sintered, and then they actually casted plastics with the help of these mold sets. Here's another design for the cooling channels. You can produce such inserts, put them into your mold, and then have the desired casted product. And we said that we can also use additive manufacturing technology to produce electrodes. Here is the example. We can, after you produce the part, let's say with FDM, you produce a weird shape, and by plating that weird shape, you can have a very special electrode for your electrode discharge machining process. But if you follow the conventional approaches, machining, then you cannot increase the complexity of your electrode. That will not be possible. But with additive manufacturing, you can obtain the geometry and then do some electroplating of copper and have the final electrodes. And also, instead of polymer technologies, you can even use some metal powder systems. Then we may also use additive manufacturing technologies for investment casting. In the investment casting, if you remember, you need to produce such patterns made of wax material. And it is easily fabricated with SLA kind of technologies. So once you obtain these patterns, then you can put them into a ceramic slurry. The surface will be covered with ceramics, and later you can simply pour metal into these openings. Since in between these two steps, you put actually this part into an oven, and this wax material is evaporated. And after this material is evaporated, what do? You simply pour your metal into these openings and have the final product. So what are the other type of systems we can use? There are many of them. I'm sorry, for instance, for vacuum forming tools, if you want to have, if this is actually the paper pulp you want to have at the end of your fabrication, you need to first fabricate this insert. And this insert is manufactured with the help of additive manufacturing. And then later, such paper pulp is fabricated on top of it. And then later you can remove it and use in your applications. And furthermore, we can use the result of additive manufacturing for composite manufacturing. We may have such tools. These are called as tools, and on top of these tools, you can actually join some carbon sheets. Such composite sheets can be put on top of each other, and later you may simply remove that composite part and use the same tool for your next manufacturing operations once again. Or later you can you can use additive manufacturing parts for measurements. You can put, for instance, such kind of boards into your additively manufactured part, do some measurements, measure currents, other things, check the size, check whether this one's fitting into the design or not. They're all possible with additive manufacturing.